Hello friends, welcome back to my YouTube channel. This is Ramdas Pandit Prasad, working as Assistant Professor in Chemistry at Maratha Vidya Prasarak Samaj, Nasik. In this video lecture, we are going to study about hydrolysis of salt of weak acid and weak base. Now consider, for example, hydrolysis of ammonium acetate is salt of weak acid and weak base. And when ammonium acetate dissolve in water, so it undergoes complete dissociation. Okay, and after dissociation, you will get what will happen? Ions will react with the OH minus ions and H plus ions of water product. Produce freely dissociate weak base, ammonium hydroxide and weak acid, that is acetic acid. So if you take the ammonium acetate into the water, it will dissociate. Okay, ammonium acetate NH4 plus and CH3COO minus. So two ions you will get. Okay, this anions and NH4 plus, this will be cation. So two ions you will get, and in water we have no H plus and OH minus is present. So they can attach with these molecules. Okay, CH3 COO minus, so it will abstract the H plus. Okay, it will abstract the H plus, so it will form CH3 COOH, and NH4 plus will go towards the OH minus ion, so it will form NH4OH. Okay, so like this combination you will see into this reaction after the dissociation of ammonium acetate. Okay, so you will see here on hydrolyzed salt. Okay, CH3COO minus plus NH4 plus. So both are we have taken into the water, so it will form free acids and free base. So this hydrolysis reaction, so equivalent amount of both hydrogen and hydroxyl ions utilized for the hydrolysis reaction, both we have seen. Okay, H plus will attach with the acid group and OH minus ions will attach with the NH4 plus. Okay, so both are equivalent amount of both hydrogen and hydroxyl ions utilized, okay, for the hydrolysis reaction, and hence the salt solution remains constant, right? And now applying the law of equilibriums, you will get, that is KH. Okay, in bracket CH3COOH and into in bracket NH4OH divided by concentration of acetate and the concentration of NH4 plus is equals to, you will see that is the free acid and this is free base. Okay, this is free acid and this is free base, and divided by both are unhydrolyzed salt. Okay, both are unhydrolyzed salt, and in this term KH is the hydrolysis constant of salt, that is KH. Okay, hydrolysis constant of salt. Now for this solution, if you will give the temperature, so the value will be changed. Now you will see the ionization of weak acid, that is acetic acid. Dissociation will occur here. Okay, CH3COO minus plus H plus. In this way you will see the dissociation for the NH4OH. Okay, ionization of weak base, that is NH4 plus plus OH minus ions, and ionization of pure water. Water can also dissociate H plus plus OH minus ions. Now by the law of ionic equilibrium, ionization constant of weak acid, that is Ka. Okay, ionization constant of weak acid, that is Ka. So you will get in bracket CH3COO minus and in bracket H plus, okay, and divided by CH3COOH. So this is the product and this is the reactant. Okay, this reaction you have to take here. Okay, ionization constant of weak acid. So the concentration of the product and divided by the concentration of reactant. And ionization of constant of weak base, okay, that is Kb. Now for the second reaction, so you will take concentration of the product divided by the concentration of reactant. Now you will see the ionization for the water, that is ionic product of water, that is Kw, and we have no concentration of H plus, that is in bracket H plus plus in bracket OH minus. Okay, so dividing the equation Kw divided by Ka into Kb, so you will write in this way Kw, this term you have to write as it is here, and for the Ka and for the Kb. Okay, this is the for the acetic acid, this is for the weak base. Okay, this is weak acid and this is weak base, NH4 plus OH minus divided by NH4 OH. So as it is we have to write in this way. So you will get like this. Okay, in bracket NH4 OH in bracket CH3COOH divided by CH3 minus acetate group and in bracket NH4 plus this is another group. So it will be the KH. Okay, hydrolysis constant of salt, weak acid and weak base. Okay, so the KH is equals to Kw divided by Ka into Kb, and so we can say for this equation hydrolysis constant of salt of weak acid and weak base is inversely proportional to the ionization constant of weak acid and weak base. Now we have to see next term, that is degree of hydrolysis, and in this case again we have to consider the hydrolysis reaction of salt. In this term small c is denoted by initial molar concentration of salt and small h is the degree of hydrolysis of salt. Now you will take this reaction, okay, acetate group plus NH4 plus water, that means you have taken ammonium acetate group, okay, into the water, so you will get acetic acid plus NH4OH. So that initial molar concentration will be C, small c, and for NH4 plus again C, and here acetic acid for the 0 and NH4OH is 0, and the concentration at equilibrium will be C in bracket 1 minus H, and again here for the NH4 plus is small c in bracket 1 minus H, and for the acetic acid CH, and again NH4OH is CH. Therefore the hydrolysis constant, that is KH in bracket NH4, okay, NH4OH in bracket CH3COOH and divided by CH3COO minus and in bracket NH4 plus. So right hand side term we have to taken at above, and left hand side we have taken here. Okay, so in this way we have to write product divided by reactant. Now to the next step you will see in bracket CH into CS divided by C square in bracket 1 minus H bracket square. So you will get is equals to H square divided by in bracket 1 minus H bracket square. And if H is very small as compared to 1, so you will write here in bracket 1 minus H bracket square is approximately is equals to 1. So that you will write here KH is equals to H square, that is the degree of hydrolysis, that is small h, right, and under root of kh. So that you can say here the degree of hydrolysis of salt of weak acid and weak base is independent on molar concentration of salt, but it is proportional to square root of hydrolysis constant, and it change with the temperature. If you will give the temperature for this kind of solution, so the hydrolysis constant will be changed for this kind of salt, and substituting the these values, okay, h, so you will get h is equals to under root of kw divided by ka into kb, right? So this equation we can use for the calculation of degree of hydrolysis of salt of weak acid and weak base by knowing the ionization constant of weak acid and weak base. Okay, now we have to see the next topic, that is pH for this salt. What will be the pH for this kind of salt, that we have to know now. And due to hydrolysis of salt of weak acid and weak base, the salt solution becomes neutral. That means the concentration of H plus, okay, in bracket H plus, and is equals to in bracket OH minus ions. So concentration of H plus is equals to the concentration of OH minus, because this is the neutral condition, right? Okay, so the hydrolysis of salt by hydrogen ions, you will see the CH3COO minus acetate group and H plus, okay, from the water. So you will get acetic acid, and the initial concentration for the acetate group is small c, and here acetic acid is 0, and the concentration are at equilibrium. So the small c in bracket 1 minus small h, and here small ch. So the reverse of this partial hydrolysis is the ionization reaction of acetic acid, its ionization constant, that is ionization reaction of acetic acid, that is Ka. So you will write here in this way, reverse partial hydrolysis, reverse here. So that's why we can write here in this way, CH3 in bracket CH3COO minus, okay, in bracket H plus divided by CH3COOH. So that the concentration of H plus is equals to Ka, and we will take the concentration of acetic acid divided by the concentration of acetate group. At the next step, you will get Ka into C into H divided by C into in bracket 1 minus H, and is equals to Ka into H. So H is the negligibly small as compared to 1. Therefore, 1 minus H is equals to 1. So the hydrogen ion concentration is equals to Ka into H. And substituting the value of this concentration of H plus and is equals to Ka. So into under root of Kw divided by Kb into Ka, okay, is equals to under root of Kw into Ka divided by Kb. And taking negative logarithm of the both side, you will write in this way, minus log in bracket H plus is equals to minus log under root of Kw into Ka is divided by Kw is equals to minus log in bracket Kw into Ka divided by Kb, okay, bracket complete, brackets 1 by 2 square. And at the next step, pH is equals to minus 1 by 2 in bracket log Kw plus log Ka minus log Kb. So the pH you will get 1 by 2 in bracket minus log Kw minus log Ka plus log Kb. And for the last step, pH is equals to 1 by 2 bracket pKw plus pKa minus pKb. And for the weak acid and weak bases, if Ka is equals to Kb, okay, ionization constant for the weak acid is equals to ionization constant for the weak base. Okay, so that what will be happen for the pH is equals to 1 by 2 pKaw is equals to 1 by 2 into 14, that will be the 7. So if you will add the same or equal amount of both solutions, you will get neutralization reaction. That means the pH will be 7, right? And the salt of weak acid and weak base with equal ionization constant are neutral.